Dear students, warm welcome to online video session 3 on cloud computing. In this session, we briefly discuss about what is cloud computing and scalability of the cloud computing, evaluation of cloud computing over past 10 years, various new paradigms in cloud computing we will discuss in this video session. Let us share PPT. This is your prescribed textbook, which will cover all first unit related stuff in this textbook. The title of the textbook is Distributed and Cloud Computing. Author is K.Venkata. So students may access this e-book copy from the internet with free of cost. So this textbook is very useful for you. So Unit 1 to Unit 5, total 5 units will be covered in this textbook. Course outcomes of cloud computing. After successful completion of cloud computing, the student will be able to describe various system models and software environments for cloud computing and distributed computing. And students will be able to analyze the mechanism of virtualization for data center automation. Students will be able to demonstrate the knowledge on cloud architectural design, cloud security, and various cloud service models. Students will be able to construct cloud-based software applications on the top of cloud platforms offering in the market. Students will be able to understand mechanism for cloud resource management applications. Students will be able to learn the privacy policy of cloud providers. So after successful completion of this cloud computing elective course, the students will be able to successfully describe, analyze, demonstrate, construct, understand, and learn various attributes. Next, move to another slide. Dear students, the topics will be covered in Unit 1 are broadly described in 5 categories, namely system modeling, clustering, and virtualization. So in today's video lecture, we will talk about system modeling, clustering, and virtualization from 1.1 to 1.1.3. These 4 topics will discuss in this today's class. Let us move to scalable computing over the internet. These are various topics covered in Unit 1. So we will discuss now scalable computing over the internet now. The scalable computing over the internet covers 3 topics, namely age of internet computing, scalable computing trends and new paradigms, IoT and cyber physical systems. So we will broadly discuss about all these 3 in detail in this video session. Here, question is, what is scalability? Sometimes we may say that scaling up or scaling down. What is scalability and why scalability is really required and how it is impactable in cloud computing? We will see in this presentation. Scalability is nothing but it is the ability of computer application or product to continue function well when it is changed in its size or volume in order to meet a user needs. Scalability means that Sometimes we may increase the size or volume of computers based on the traffic needs. Best example is sometimes the servers are running with a huge traffic and sometimes the servers are running idle. When the servers are running with a huge traffic, to control the traffic over the internet, the servers will be scaling up automatically. When the servers are sitting idle, meanwhile, to scale down the traffic over the server, which means that based on the requirement, the scalability will be up or the scalability will be down automatically. That is known as scalability computing, which may impact that the volume or the size of the storage or speed will be automatically scaled down and scale up based on the requirements of the customer. That is called as a scalability. Now here we will see scalable computing over the internet. Instead of using a centralized computer to solve computational problems, a parallel and distributed computing system uses multiple computers to solve large scale problems over the internet, which means that so sometimes we need to scale up. That means that increasing the speed and the storage capacity of the computer. For that, the best solution is instead of setting your computer using a single computer, better you go for a parallel computing or distributed computing. So, what is parallel computing and what is distributed computing? How it is differ with a centralized computing? We will discuss now. So central computer computing is nothing but there is only one central server. All the clients are internally connected to that central server, and they may access or they may retrieve the data from the server itself. If we are working on central computers, if the server is damaged, the entire process will be problem. The entire process will be stopped. To overcome the problem, instead of using centralized computer or computing, we suggested go for parallel computing or distributed computing. Thus, distributed computing become a network-centric or data incentives. Here, we will talk about the age of internet computing. What is internet computing and what is the age of internet computing? The age of internet computing is mainly depends on two computing techniques, namely HPC and HTC. HPC stands for one is performance computing and another one is throughput computing. Performance computing is nothing but meanwhile if the computer is running with a huge traffic, we need to attach bulk servers and we need to attach bulk storage capacity. So that is called as a increasing the performance in terms of computing is known as high performance computing. And HTC, high throughput computing. So here, high throughput computing, we basically use in parallel and cloud computing techniques and distributed computing techniques. So in parallel and distributed computing techniques, the high throughput computing systems are built in. Whenever we need to scale up, automatically the data servers are upgraded by themselves, due to which fast servers and storage systems will be available and high bandwidth network is also available. So this is the difference between high performance computing and high throughput computing. These two will be used in the age of internet computing. Let us take a simple example of HTC. HTC is nothing but high throughput computing system. The best example is parallel computing and distributed computing technologies. Take an example. Suppose if you have to process 100 video clips and each one takes 1 hour time or duration, then you would need 100 hours of computing time on your laptop. However, if you had 100 laptops, you could theoretically do the task in 1 hour, assuming that you could instantly command each one to begin the processing task. This means that suppose you have 10 video clips and each video clip will take 1 hour duration for performing. So to process 100 videos with a duration of 1 hour each, how many hours you really require is 1 hour into 100 videos. That means that 100 hours you need, but it is time consuming. So to overcome the problem, what we will do, we just move to centralized computing into a well-known distributed computing. In distributed computing, what we will do is we are allocated 10 different laptops for completing 100 videos. So it will lead to minimize the computing time. So to overcome the problem, instead of setting up the server in a distributed system, centralized system, we simply move for distributed computing. So this is the example for high throughput computing. Here we will see the evaluation of cloud computing over past 10 years. The cloud computing is an emerging area and trend now, but it was started in the year, it was initiated in the year 1950. So during the term period 1950 to 1970, 20 years duration, so mainframes included, IBM was introduced, IBM mainframes. And these mainframes will be mainly used government organizations and large business people are used in the age of 1950 to 1970. So that means that IBM we are using with the help of mainframes during the period 1950 to 1970. So this will fulfill the needs of government and large business systems. So later on, in 1960, low-cost mini computers are introduced. We can say that as a mini computers are introduced in the 1960 year, and this became very popular for performing various small business as well as colleges or educational institutions. They are very familiar. Low minimum mini computers. Next, in the year 1970 to 1990, during this 20 years period, personal computers, PC, we just shortcut call as a personal computers came into the picture. The personal computers are running with VLSI microprocessors. And later in the year 1980 to 2020, during this period, massive number of portable computers and pervasive devices appears in both wide and wireless applications. So this is an emerging technology or area. The wireless communication will be initiated during the period of 1980 to 2000 period. So wireless technology is nothing but over internet, it can be applicable only. So later, recently in 1990, since 1990 onwards, HPC and HTC systems came into the picture, which means that high performance computing systems and high throughput computing systems. These two are hidden and clusters and grids are internally set up in those systems, and the internet clouds also populated in those systems. Here, HTC and HPC are computational grids, which means that these are performing better way compared to mainframe computers, mini computers, personal computers running with VLSI microprocessors. Now here let us see the evaluationary trends towards parallel, distributed and cloud. So observe here what is parallel computing and what is distributed computing and what is cloud computing. So the picture will clearly identifies that parallel, distributed versus cloud computing. So now I will explain this architecture of evaluationary trends towards parallel, distributed and cloud computing now. So on the HPC side, high performance computing side, supercomputers are gradually replaced by the clusters of cooperative computers to share the computing resources. Here, a cluster or MPP, cluster is often called as a collection of homogeneous nodes or computers that are physically connected closely to one another. So this is called working on the principle of parallel computing. On the other side, HTC side, the HTC stands for high throughput computing system. Here, the high computing throughput systems are connected to P2P network. P2P network will be worked on the principle of distributed computing. P2P computer, P2P network are formed for distributed file sharing and content delivery applications. A P2P system is built over many client machines and peer machines are globally distributed in nature. The P2P cloud computing and web services and web services platforms are more focused on HTC applications than on HPC applications. Here, clustering and P2P technologies lead to the development of computational grids or data grids. So here we will compare only three categories, three computing techniques here. One is parallel, another one is distributed, and another one is cloud. The cloud here, if you observe that Web 2.0 service is a cloud, Internet cloud is also one of the cloud, IoT is also considered as a cloud. All these cloud computings are well connected to the grid that is known as computational and data grid. So the computational and data grid is well connected to the internet cloud by using virtualization concept, and the data grids are well connected to the web services, and we can access the services through SOA, stands for service oriented architecture, and the internet of things will be considered as a cloud, and it can access the data from the data grids with the help of RFID and sensors also. Here, one more distributed computing technique is there. So that is P2P network. P2P network is work on the principle of distributed computing. It can receive the data from HTC and then it can process the data to the data grids with the help of distributed computing. And here the cluster or MPP, cluster is nothing but a collection of homogeneous nodes that can be well connected each other, and it is working on the principle of parallel computing. Parallel computing. And finally, I can conclude that HTC systems and HPC systems will be playing an important role in the evolutionary trends of both parallel computing as well as distributed computing over past 10 years. Next, what is cloud computing is and what are the new paradigms we will discuss here. As I said that in last slide, IoT we are using for to access the data from the grids. IoT is using RFID. RFID is the card. The card can be remotely accessed over the internet. RFID stands for radio frequency identification. Radio frequency identification. This type of RFID cards are using in software industries or in hospitals, multinational hospitals. So here if you observe the picture, a person swapping the card over the door. So when the data communicated with the RFID card, automatically it passes the signal and the door will be unlocked automatically with a huge security. This type of RFID cards will be using opening the doors in hospitals and entering into a software industries. The employees are maintaining RFID cards also. And second one is global positioning system. Simply we can call as a GPS. Global positioning system is nothing but we can track the vehicle where it is located and we can track our geographical location where we are. That can be do with the help of the GPS. This is also another cloud computing trend and new paradigms nowadays. And next one is IoT, Internet of Things. This IoT will be worked with the help of sensor technology, and the sensors has triggered with the development of IoT nowadays. Next. What are various computing paradigms? As I already said that these are three computing not limited to three, five total computing paradigms are there. They are distributed computing, parallel computing, cloud computing, utility computing, and cluster computing, and grid computing. What it is, what is distributed computing, what is parallel computing, what is cloud computing, and what is grid computing, what is utility computing, and the difference among those we'll discuss in this slide. So now we will discuss about centralized computing. What is centralized computing means? In the centralized computing, it is a computing paradigm by which all computer resources are centrally connected physically to a particular system is known as central centralized computing. In the centralized computing, only one server here we are maintaining. So there are many client systems are well connected to the server through a single network. Many data centers and supercomputers, which means that clients are centralized to the system, but they are used in parallel, distributed, and cloud computing applications over the internet. This centralized computing, in the centralized computing, the resources like processors, memory, storage are fully shared and tightly coupled with the integrated with the operating system. And next move to another one is parallel computing. What is mean by parallel computing? In parallel computing, all the processors are either tightly coupled with centralized shared memory or loosely coupled with distributed shared memory. Interprocessor communication is accomplished through shared memory via messages that is known as parallel computing. If you observe the difference between both central computing and parallel computing, in parallel computing, only one common memory, many processors are working with the are working and they are storing their data by accessing a centralized memory that is called as a parallel computing. Many processor 1, processor 2, processor 3, these three are working parallelly with a single memory that is called as a parallel computing. In the distributed computing, and each computer is having their own processor and their own memory in the distributed computing. So these well-defined computers are well connected to each other. What is distributed computing and how it is differ with cloud computing? We will discuss now. Distributed computing means a group of computers working together as to appear as a single computer to the end user is known as distributed computing. When we are using distributed computing is in the centralized computing only we can perform the task at a time. If you want to perform huge number of tasks simultaneously at the same time to overcome the problem, instead of going for centralized computing or distributed computing, centralized computing, we move to distributed computing. In the distributed computing, the distributed systems consists of multiple autonomous computers and each is having its own private memory and they can be communicating through the computer networks over the period of time. Best example for this distributed computing is ATM machines, wireless ad hoc networks, internet and intranet. These are well-defined examples for distributed computing. If you consider ATM machines, we can say that only one machine is there, but internally, if you consider ATM machine is working with many other computers, they are located in different places. And the property, one of the familiar properties of distributed computing is fault tolerance, load balancing, and resource sharing. What is mean by fault tolerance? Fault tolerance means that when two or more nodes are internally connected together, if any one of the node or computer fails, the whole system may not be suffer, and it can be divert the network to the other computer. The whole system can still working in a fine mode, so we don't bother about that. So to overcome the problem, instead of that using distributed, instead of using centralized network, we simply move to the distributed network. And what is cloud computing? How it is differ with the centralized computing and distributed computing? We will see now. The cloud computing is an internet computing technology, and it can be used the resources available over the internet in two modes like distributed mode as well as a centralized mode. The cloud applies parallel or distributed computing, or sometimes we can apply both parallel as well as distributed based on the customer requirements. And cloud computing technology, clouds can be built and they are maintaining physical or virtualized resources over the large centers that are centralized and distributed, which means that whatever the data centers hosted into the cloud vendors, those are centralized or those are distributed based on the customer requirement. They may design and they may develop over a point of view. Now here we will observe the difference between distributed computing and cluster computing. So we already discussed what is distributed is. Now move to cluster. Cluster means what? Cluster means a group of servers. Cluster means a group of servers that are combined or grouped together to achieve the task like a business task. That is called as a cluster computer, clustering computing or cluster computing. Whereas distributed computing refers to splitting or divide the large problem into smaller sub-problems, and we can perform the task very easily. So a business divided into different businesses and we are assigned one computer for performing the task. So for that we need to easily solve the complex problems. This is the difference between distributed systems and a clustering computing technologies. And what are various applications available or supported for HTC, high throughput computing, and high performance computing system? We'll discuss in this slide. If you observe here, various domains are available. Science and engineering is one domain. Business, education is, and healthcare industry is another domain. Internet, web services, and government applications is another domain, and some more mission critical applications. How the HTC and HPC will be impact on this domain, we'll see here. If you consider an engineering domain or science domain, and scientific simulations are developed, and some of the earthquake predictions also measuring with these applications. And weather forecasting also we can done with the help of high throughput computing and high performance computing technology in the domain of science and engineering. Let's move to another domain, healthcare domain or business domain or educational domain or industry domain. So here these are well familiar with the some of the specific applications like telecommunications and e-commerce also, and banking sectors, stock exchange. So for airline monitoring, traffic control over the air force, and power grids, maintaining the power grids over the period of time and measuring the distance from one place to another place, and healthcare setup in the hospitals, and autonomous autonomization of hospitals in a network, And nowadays it is one of the familiar one is telemedicine. So all these well-known familiar applications which can be implemented with the help of high throughput computing and high performance computing. And some of the government applications also defined or developed with the help of HTC and HTHPC systems. These are internet search, right? Google search, and maintaining the data centers in a premises, online premises, and a decision making system, which means that AI, artificial intelligence, and working on that and monitoring the control of the traffic and the cyber security threats prevention. These are various applications we are performed with the help of HTC and HPC systems. And some of the critical applications also they may handle. These are military command control and intelligence systems work on machine learning or deep learning or some other critical management systems also supported with the help of HTC and HPC systems. These are HPC and HTC are well familiar internet cloud computing techniques. And next one is utility computing. What is utility computing? How it is differ with the distributed computing? We will discuss in this slide. Utility computing is nothing but it considered as a better computing technique than cloud computing. It may act as a better computing technique than cloud computing technique. So in our daily life, we are done doing payments like electricity bill, water bill, and various computing bills and gas bills, not limited to those. So in our day-to-day life, we are doing or we are communicating these bills, utility bills automatically. So this can be performed with the technology that is known as utility computing. Utility computing is nothing but service provider. It is a service provider that can be computing the resources and infrastructure management available to the customers as they need it, and they may charge them for a specific usage rather than a flat rate. So that is called as a utility computing. Some of the computing paradigms here listed here: cloud computing, peer-to-peer computing, grid computing, service computing, data centers computing, web services, and utility computing. But among those listed computing paradigms, utility computing paradigm is one of the better performing paradigm nowadays. Here, HTC is used in business applications, whereas HPC will be used in scientific applications for the performing with the help of the utility computing technology. Let us move to another slide. What is IoT and what is cyber physical systems we will discuss now. As we discussed in earlier slide, IoT is working with sensors only. IoT is working with sensors and we are using RFID cards for performing this IoT whenever we require. Smart door lock and smart door unlock. These activities are related to IoT technology. So using this IoT technology, we can lock the door automatically, we can unlock the door automatically with the help of RFID cards. Internet of Things is about connecting things. Here the things is nothing but any object available in the market, object like is a fan, a controlling a device, a car, anything or a machine or an object which can be well connected and to the internet, and those connected devices can be controlled by the help of IoT smartly. And these objects and machines are interconnected together and they are posted into the internet over a period of time. So IoT is a networked connection of everyday objects including computers, sensors and humans, not limited to those. And next one is cyber physical systems. Simply we can call it as a CPS. CPS are integration of computation, networking and physical process. It is a combination of or integration of computation technologies and various networking technologies and physical process technologies into a single platform that is called as a cyber physical systems. Thank you, students. In this session, unit, we talked about evaluationary cloud computing and when cloud computing initiated and what is the latest technology we are adopting in the cloud computing we discussed and various new paradigms over the internet with the help of cloud computing, how it is differ with the distributed computing, how cloud computing will be differed with other computing techniques like clustering computing, grid computing, parallel computing, and distributed computing, and how cloud computer utility computing is performed better than cloud computing, and what is IoT, how exactly it is useful, and various edge cloud computing techniques like HPC, high throughput computing, and HPC, high performance computing techniques will discuss in this video. So I am closing the session. Thank you. Thank you, Ananda.